Hi, I'm Emily from emilylearning.com. In this video, I'll be sharing with you what's tested in the chapter on practical electricity. So let's get started. Before I go on to our topic, I would like to share with you some of the resources that I've created recently. So one of it is the O-level physics formula. So in this blog article, I go through or I list down all the physics formulas that you need to learn from each topic. Okay, I've also provided a list of physics definitions here. So you'll find all the common definitions that you need to know for your O-level physics exams. And you can find them at this link here. So I provide the link in the description below. I also provide individual links for this blog post on the O-level physics formula and the O-level physics definitions. Okay, so now let's go back to our topic. The best place to look at what is tested is to look at the syllabus. So here we are at the syllabus. So I'll go through point by point what's covered. So firstly, under practical electricity, you need to be able to describe the use of heating effect of electricity in appliances such as electric kettles, ovens, and heaters. Basically, what this means is that you need to know the energy conversion. Okay, so for such appliances like electric kettles, ovens, and heaters, the main source of energy that we need from them is heat. So electrical energy is being converted to heat energy when we use these appliances. Next, you need to be able to make use of this formula. Power equals to potential difference times current, and energy equals to power, which is VI, or potential difference times current times time, to solve questions. Okay, so take note for these equations here. Okay, in particular for this time here, so I think you should know that potential difference should be in voltage, current should be in ampere, energy will be in joules, and time will be in seconds. For this formula here, power is in watts, potential difference is in volts, and current is in ampere. Okay, so take note for most questions, right, as long as you are not calculating the cost of electricity, the energy formula, the V and I are in voltage and in ampere, and time will always be in seconds. Okay, and your energy's unit will be in joules. Okay, that is for most scenarios. But when you are going to calculate the cost of using appliances, okay, where the energy unit is kilowatts hour, then what you need to remember is you still calculate power using VI, where V is in voltage and I is in ampere, and power is in watts. But then your power must be changed to kilowatts. Okay, so kilowatts, so 1 kilowatt is equals to 1000 watts. So if you have power in watts, you need to divide it by 1000 to change it to kilowatts. Then you must make sure that your time is in hours. Okay, then you can find energy in kilowatts hours. Once you have found energy in kilowatts hours, that refers to 1 unit of electrical energy. Okay, when we are calculating cost of electricity, then multiply it by the cost per unit to find the total cost of using the appliance. Next, you need to be able to compare the use of non-renewable and renewable energy sources such as fossil fuels, nuclear energy, solar energy, wind energy, and hydroelectric generation to generate electricity in terms of energy conversion efficiency, cost per kilowatts hours produced, and environmental impact. Usually for part D, right, the questions that come up will be the database questions where they give you a paragraph or some text, you read it and be able to infer from the text some information regarding energy conversion efficiency and so on. Okay, so basically for part D, right, what is important is you know the differences between renewable and non-renewable resources. So non-renewable resources are mainly your fossil fuels such as natural gas, coal, and your oil, crude oil. Okay, and in Singapore, right, most of our energy comes from burning of natural gas at the power station. Of course, we do use some other fossil fuels, but the majority is still natural gas. Okay, and we are also looking at increasing our electrical energy produced from solar energy. That is why in recent years you notice a lot of solar panels being installed all over Singapore. For example, just last year I noticed a lot of solar panels being installed at the roof of my HDB flat, okay, as well as my neighbors. Okay, so the reason for using solar energy is because firstly it is clean. Okay, when you burn fossil fuels, it produces gases, greenhouse gases like carbon dioxide, and because fossil fuels contain small amount of, no matter how you treat, it will still contain small amount of sulfur, so you will end up having sulfur dioxide or oxides of sulfur being produced. And at high temperatures, when you burn something, nitrogen and oxygen combines to form oxides of nitrogen. So there are quite a lot of um, acidic gases and greenhouse gases that are being produced when we burn fossil fuels. But when we use renewable resources, like for example, nuclear energy, solar energy, wind energy, hydroelectric um, power, what happens is, right, the production of energy from these sources are very clean. So if you were to use a solar panel, you place a solar panel there and it produces electricity, right? It converts solar energy to electrical energy. You do not burn anything. It's very clean and it is very cheap. Okay, but the expensive part for all these renewable resources, right, doesn't come from the production. It comes from creating the infrastructure or the equipment in order to produce the electricity. So the cost of producing solar energy is basically the solar panels plus the electrical boards, right, connected to the solar panel so that it can transmit the energy to us. Okay, so once you have created the infrastructure, the rest of it comes from maintenance, right? Okay, so in Singapore, basically our energy comes from mainly the burning of natural gas and also increasingly from solar energy. Okay, we are not able to explore wind energy and hydroelectric generation. Reason is because we do not have consistent strong winds or we do not have high energy waters from rivers, from fast flowing rivers and so on. That is why we have not been considering this too. Okay, so you'll notice that for a lot of the renewable resources, right, another issue with them is the consistency, and it is not available everywhere. Okay, so for Singapore, we do not have consistent strong wind, so probably wind energy is not something that we can explore into. Okay, okay, then we also have nuclear energy, which is a source of renewable energy. I know many people will be saying that, hey, the nuclear waste, they are not clean, right? Definitely, they are not. So the problem with nuclear energy is the waste that is being produced. Okay, so the waste that is being produced, they are radioactive. They have to be kept in maybe lead boxes and buried deep inside. So because of these issues, in Singapore, we have not yet explored this. And because we are a very small country, right? I mean, if there's any issues, the whole country will be affected. So it is something that I believe, okay, that we will not be exploring anytime in the near future until technology advances have solved the issues of how do we treat the waste from nuclear energy. All right. So basically for this is basically knowing the type of renewable resources that we have, uh, the that we can generate electricity from, as well as our current um, conventional way of generating electricity by burning fossil fuels. Okay. And most of the questions that involved here will be for a data response question. Okay, now that we have talked so much about part D, let's go on to part E. So in part E, you need to be able to state the hazards of using electricity in damaged insulation, overheating of cables, and also in damp conditions. Okay, so basically, damaged insulation, what happens is if someone touched the damaged insulation that is live, they can get an electric shock. Also, if you have damaged insulation, remember that inside your wires, right? We always, okay, so for most of our appliances, we use a three wire. So you have an earth wire, live wire, and neutral wire. So if there is a damaged insulation within this live wires and neutral wires and earth wires, right, what happens is the live wires could be touching the neutral wire directly. So when that happens, right, you have a short circuit. It bypasses the electrical appliances, then it just goes through the live and the neutral wires. And when there's a short circuit, there's a very high current that passes through. So very high current, it will be very hot. It could also result in further damage of equipment and so on. Okay. Okay, overheating of cables, you can cause the insulation to melt and so on, and you can also have a short circuit. For damp conditions, you can because water can conduct electricity. Okay, it is not a good conductor of electricity, but it can conduct electricity partially. So when you have water, you can also cause a short circuit. Okay, so basically just learn the hazards and be able to explain these situations. Okay, in F, you need to be able to explain the use of fuses and circuit breakers in the electrical circuits and fuse and of fuse rating. So I have also provided the purpose of a fuse and why they are important. Okay, in my list of definitions for O-level physics, so do check that out. Okay, same thing for earthing of metal casing. So I also provided a definition or what is earth wire and its purpose. Okay, and also for double insulation. So do check out the blog post on a list of physics definitions. How I've included them there. Okay, then same thing, you need to be able to state live, neutral, and earth wires. Okay, so I've also provide this the meaning of these wires, what the live, neutral, and earth wire means in that blog post on definition of the definitions of the list of definitions for O-level physics. Okay, and also for the live, neutral, and earth wires, right? You also need to be able to label them. Okay, so this is the a 3-pin plug. Okay, so the one at the top is the earth wire and it's usually green or yellow. Okay, then you have the live wire, which is here. Okay, and it is where the fuse is connected to as well. Okay, so your fuse is connected to the live wire, so it's here. So and the live wire is usually brown color. Then you have the neutral wire, which is here, the blue one. Okay, so this is how the 3-pin plug looks like and how we have these three wires, the live, the neutral, and the earth wires. Okay, so this sort of summarized part I describe the wirings in the main plug. So you need to be able to identify the different wires, whether it's live, neutral, or earth, the colors, okay, yeah, in the plugs. Okay, then next you need to be able to explain why switches, fuses, and circuit breakers, they are all connected to the live wire. Okay, the reason is because the live wire is where it is being connected to the high voltage supply. So if we want to cut off an electrical, so if we want to cut off the current, we always want to cut it off at a high voltage supply so that it is safe for user. All right. Okay, so that basically sums up what you need to learn for this chapter on practical electricity. I do have a course where we go run through this entire chapter in detail together with topics like DC circuit, current electricity, as well as static electricity. I'll provide a link below, so do check that out if you are interested in that course. Thank you for watching this video. Do subscribe to keep updated with our latest videos. And if you are interested, we do have an entire playlist on all the topics tested in physics O-level, where we share with you what is tested in detail. Okay, in addition, if you want to learn in detail, do check out our courses on Udemy. Bye and see you.